Hey guys, it's Miss Miklos, and in today's lecture we are talking about trigonometric functions of any angle, and that means we are going to explore all four quadrants in addition to dealing with quadrantal angles. So I want us to start here by labeling our x-axis and our y-axis. And we're also going to go ahead and label all four of our quadrants. So we know that those go in a counterclockwise manner. And I'm going to plot an ordered pair in quadrant 1, and I'm going to call it x, y. Okay, so that just means it could be any ordered pair that we want. We know it's x because it's moving to the right, it's a positive value, y because it's moving up. And the way that we always draw a right triangle if we are given a particular ordered pair is that we're going to draw a line straight down to the x-axis, and I'm going to draw a line from the origin to that point. We call the angle that is closest to the origin our reference angle. And so I'm going to take a moment and just talk about the signs of each side. So I know opposite, I see this is going up, so it is positive. Our adjacent side is going to the right, so that is positive. And the hypotenuse is always positive, so I'm also going to say that that is positive. So if we think about this, some things I want to point out in quadrant 1, sine is greater than 0, and all this means is that the sine value is going to be positive. The reason why it is positive is because it is going to be sine is opposite over hypotenuse, which would be positive over a positive, which gives us a positive ratio. Next, for cosine, adjacent over hypotenuse, I have a positive over a positive again. So I'm going to say cosine of theta is greater than 0. Tangent, opposite over adjacent, I have a positive over a positive once again. So I'm noticing that all three of these trig functions are positive in quadrant 1. Now notice I'm just focusing on these three, but we know that their reciprocals would also be positive because if I flip a positive fraction, it stays positive. Okay, in quadrant 2 now I'm going to go ahead and label this ordered pair negative x, y. And I'm going to draw straight down to the x-axis and draw a line to that ordered pair. And once again, we have theta here. And the reason why this time I labeled it negative xy is because I'm moving from the origin to the left side, so that's giving me a negative direction. And then our y value is moving up, so that is positive. So I'm going to put negative and positive and positive. So if we take a look, this time, for sine, cosine, and tangent, I notice that sine, opposite over hypotenuse, is a positive over a positive, which means it has to be greater than 0. Cosine, adjacent over hypotenuse, if I have a negative over a positive, that gives me a negative number, which means cosine is less than 0. Tangent, opposite over adjacent, a positive over a negative, also tells me that tangent is negative. So we notice here sine is the only value that's positive, and that is because both the opposite side and the hypotenuse are positive in quadrant 2. Okay, in quadrant 3 here, I'm going to plot another ordered pair, and this time I'm going to call that negative x, negative y. And the reason why this time is because it is going down and to the left. So I'm going to label this theta. This is negative, negative, and positive. So our opposite is negative, our adjacent is negative, my hypotenuse is positive. So if I am looking at those three trig functions again, sine, cosine, and tangent, also just a note that I am writing our angle because we know a trig function does not exist without an angle. Okay, sine, opposite over hypotenuse, I get a negative ratio. Cosine, adjacent over hypotenuse, I get a negative ratio. And tangent is opposite over adjacent. A negative divided by a negative is a positive. So I notice tangent is the only value that is positive in quadrant 1. In quadrant 3. This would be a giant 3, not a 1. Okay, last but not least here. In quadrant 4, I'm going to go ahead and plot an ordered pair, and I'm going to call it x, negative y. And I'm going to draw a line to the x-axis and to the origin to give us our triangle. Okay, once again, we have theta here. This time my opposite side is negative because it's going down. My adjacent side is positive, and my hypotenuse is positive. So if I'm looking at sine, cosine, and tangent, I notice sine, opposite over hypotenuse, gives me a negative ratio, so I'm going to say it's less than 0. Cosine is adjacent over hypotenuse, which gives me a positive ratio. Tangent is opposite over adjacent, which gives me a negative ratio. So this actually tells us why things are the way they are. Why is sine always positive in quadrant 1 and quadrant 2? Okay, so it is helpful for us to know. And in fact, you guys may have heard of the saying, I'm trying to color code it here, students take calculus. And what this means, and we can visually see this now looking at this, is that in quadrant 1, all trig functions are greater than 0. They're all positive. So that's the A. For students, that means in quadrant 2, sine is our only ratio that is greater than 0. Everything else is going to be negative. In quadrant 3, that take means tangent is positive. And then last but not least, in quadrant 4, cosine is positive. So we're going to use this to help us on these next few problems here. So it tells us to state the quadrants in which the angle theta lies. So it's asking us, in what quadrant is sine greater than 0? So we can actually go ahead, and this looks huge. Sorry, my cat is meowing. Okay, but if we look at this, I can see that in quadrant 1, sine is positive, and in quadrant 2, sine is positive. In our other two, it is negative. So we're going to go ahead and go back to this right here. Sine of theta is greater than 0 in quadrant 1 and in quadrant 2. Okay, the next one says cotangent of theta is less than 0. And you may be thinking, shoot, we never talked about cotangent. But I know that cotangent is the reciprocal of tangent. So I need to look and see what quadrants is tangent negative in. So let's kind of zoom out again here. And if I look, tangent is negative in quadrants 2 and in quadrant 4. So I'm going to go ahead and write that my answer is quadrant 2 and quadrant 4. Okay, so from here on out, I'm not going to zoom in on the graph. Hopefully you guys can do that on your own if you need to. Okay, but I think it's super helpful for us. So let's look at secant. Once again, I know secant is really cosine, so I need to think what quadrants is cosine positive in. And it is positive in quadrant 1, and it is also positive in quadrant 4. So let's step it up a notch here. Okay, number 4, it's asking us, in what quadrant is sine negative and cosine is positive? So the way that I think is easiest is to look at these as two separate problems and then look and see what do they have in common. So I know sine is positive in quadrants 1 and 2. Cosine, oh, I'm sorry, it did not say positive, did it? It says negative. So if it's positive in 1 and 2, that means that it is negative and in 3 and 4. Cosine is positive in quadrant 1 and in quadrant 4. So if I look at these, I notice that quadrant 4 is what they have in common. So that is our answer. That is the only quadrant in which sine is negative and cosine is positive. Okay, and our last one of these we're going to do, okay, tangent is positive and cosecant is negative. And I know cosecant is really like sine. Okay, tangent is positive in quadrant 1 and in quadrant 3. Cosecant is negative in quadrants 2 and in quadrant 3. So if we look, I notice that they both have quadrant 3 in common, so that is going to be our answer. Okay, so now we're going to put this to use. It gives us an ordered pair, and we're going to have to figure out all 6 trigonometric functions. So our first ordered pair is 4, 3. I know that 4, 3 has to be somewhere in quadrant 1. Okay, I definitely do not need to be to scale, but it just means that I am going to go ahead and sketch a triangle in quadrant 1. Now 4, 3 means that it's going to the right 4 and up 3. So that means that my adjacent side is 4 and my opposite side is 3. If we use Pythagorean theorem, we would find that our hypotenuse is 5. Now, kind of a side note, we learned that in quadrant 1, all trig functions are positive. So that's just something that is good to double check once we have a final answer. So if I look at this, I might actually label these opposite, adjacent, and hypotenuse. I know sine is opposite over hypotenuse, so I end up getting 3/5. Cosine is adjacent over hypotenuse, which is 4/5. Tangent is opposite over adjacent, which is 3/4. Now we're going to deal with our 3 reciprocal functions. The reciprocal of cosecant is sine, so I have 5/3. The reciprocal of secant is cosine, so I have 5/4. And the reciprocal of tan is cotangent, so I have 4/3. It would make sense that all 6 of these are positive ratios because our triangle was in quadrant 1 and all trig functions are positive. Okay, our next one, I have -8, -15. So I know that that has to be somewhere in quadrant 3 because that's how we go left and and down. So -8, -15 is my ordered pair there. So my adjacent side here is -8. My opposite side is -15. Now, in a previous lesson, we talked about the fact that sides of a triangle cannot be negative. However, in this case, this negative is just telling me a direction. If we use Pythagorean theorem, I end up getting 17 as my hypotenuse. And if we think about it, in quadrant 3, only tangent should be positive. Okay, so that should be something that we should use to double check our final answer. So if I am doing, let me kind of zoom out again. Okay, if I'm doing the sine, sine is opposite over hypotenuse, and let me label that with an H. I would end up getting -15/17. Adjacent over hypotenuse is cosine, so I get -8/17. Tangent is opposite over adjacent, so I get -15/8 or 15/8. Our next 3 are reciprocals. Cosecant is going to be -17/15. Notice I can just put the negative out in front. It doesn't need to stick with either like the numerator or the denominator. It's just out in front there. The reciprocal of -8/17 is -17/8. And the reciprocal of 15/8 is 8/15. So just to double check, I want to look and see, is only tangent positive? And we notice tan is positive, Cotangent is also positive, but that would make sense because those are reciprocal functions. Last but not least, I have radical 3, negative 1. So this means I'm going to the right and I'm going to go down. So let me move there. So that is going to be in quadrant 4. So I'm going to go ahead and draw radical 3, negative 1 in quadrant 4. That means I'm going to the right 3 and down 1. I'm going to use Pythagorean theorem here because it is not one of our Pythagorean triples. So I get 3 plus 1 equals c squared. 4 is c squared. 2 is our c value. Now our hypotenuse is always a positive value, so I'm going to go ahead and write it just as 2. So once again, I have opposite, adjacent, and hypotenuse. And I know that in quadrant 4, cosine is always going to be greater than 0. Everything else should be negative. Okay, so let's find the sine. We know sine is opposite over hypotenuse, so negative 1 over 2. So I'm going to go ahead and bring it up here. I know that the reciprocal of sine is cosecant, and to save me some time from scrolling back and forth, I'm just going to write cosecant of theta is negative 2. Okay, going back. Cosine is adjacent over hypotenuse, so I have radical 3 over 2. So I'm going to make cosine radical 3 over 2. Secant would be 2 over radical 3, which we would write as 2 radical 3 over 3. Last but not least, tangent is opposite over adjacent, so I have negative 1 over radical 3. So I'm going to write this as negative radical 3 over 3, and the reciprocal of that is actually just negative radical 3, sorry. And if we look at these 6, I notice the only ones that are positive are cosine and secant, and that matches the information that we wrote down earlier. Okay, so whenever we're drawing out these triangles, just a reminder, we always draw to the x-axis and we draw from the origin. Our reference angle is always the one closest to the origin. Okay, so we're going to create this quadrant again, but this time we're going to just talk about the quadrantals. So I know once again this is x and this is y, and this is quadrant 1, 2, 3, and 4. And we learned that we can think of this as 0 degrees, or we can think of it as 360 degrees. We could also think of it as 0 or 2 pi. Okay, up top, this is 90 degrees, or we could think of it as half of a semicircle, which would be pi over 2. Our negative x-axis would be 180 or pi because it is a semicircle. And then down below, this is 270 degrees or 3 pi over 2. And I definitely think that the easiest way to think about our quadrantals is going to be using the ordered pair. So I'm just going to write off to the side here just so we remember. Sine of the angle is y. Cosine of the angle is x, and tan of the angle is y over x. Okay, so definitely something for us to memorize. Now our ordered pairs. Okay, if I'm going out on this axis, remember with our unit circle, that means I'm going to the right one and I'm not moving up or down at all. So that gives me an ordered pair of 1, 0. Okay, on the y-axis, this gives me an ordered pair of 0, 1 because I'm only moving up from the origin. I'm not moving to the right or left at all. At pi, we would say this is negative 1, 0 because I'm moving to the left one. I'm not moving up or down. And then finally, we would also call this 0, negative 1 because we're moving down 1. We're not moving to the right or left at all. So this is 0, negative 1. So I think the best method to do is memorize those 4 ordered pairs or just know logically how to find them and then use these values. Now, technically, we can draw a triangle, and the tricky thing is it's not really a triangle. Okay, and that's why it can get a little bit confusing. So I just want to kind of demonstrate this to us. We know we always draw something by going down to the x-axis and to the origin. Now the problem is, since it's going to the right one and it's not moving up or down at all, we know this is not a real triangle because a triangle cannot have a side of 0. So we're just pretending that this is 0. Okay, that's our theta. And our hypotenuse would also be 1 because this is a unit circle, or we could use Pythagorean theorem and realize, okay, 1 squared plus 0 squared is 1 squared. Now, our next one, okay, if this time I'm going to kind of put the point up here a little bit and draw it like this, and here's theta, because this time I'm not moving right or left at all, and I'm just moving up 1. So I can see this time my opposite side is 1, my adjacent side is 0, and my hypotenuse is 1. Okay, for our next one, let's see. Okay, there's theta, and I have 0, -1, and 1. And then last but not least here, trying to find a different color to use. I'm going to go ahead and use it kind of off to the side here. So there's theta. We would call this -1, 1, and 0. Okay, so these triangles are kind of weird. I personally think they're a little confusing, but for some of you, you might like using them, okay? So I just want to demonstrate. So for example, sine of 0, if I'm looking at this triangle, sine is opposite over hypotenuse, 0 over 1 is 0. The other way we could do it, if I just know this ordered pair, sine is the y value, which is 0. So we could use either of those two methods. I highly recommend using the ordered pairs, but you can use whatever's easiest for you. So we're going to evaluate the 6 trig functions for the 4 quadrantal angles. And I just want to remind you that 0 and undefined are reciprocals. Running out of room there. There we go. Okay, because we know 0 is 0 over a number, undefined is a number over 0. So we're going to see that quite a bit. So we have 0 here. I'm going to remind us that that is an ordered pair of 1, 0. So sine is the y value, which is 0. Cosine is our x value, which is 1. Tangent is y divided by x. You guys may also remember from last year, tangent is sine over cosine, so we could always use that as well. 0 over 1 is 0. Now we're going to go ahead and find reciprocals. The reciprocal of sine is cosecant, so the reciprocal of 0 is undefined. The reciprocal of secant is cosine, the reciprocal of 1 is 1. And then lastly, I know tan and cotangent go together, and the reciprocal of 0 is undefined. Okay, so if I know these ordered pairs, and I know sine is y, cosine is x, tangent is y over x, it's pretty straightforward. Okay, pi over 2, that is an ordered pair of 0, 1. So my sine value would be 1, because that's the y value. Cosine would be 0, because that's our x value. Tangent is undefined because I get 1 over 0, which is undefined. Cosecant is the reciprocal of 1, which is 1. Secant is the reciprocal of cosine, which is undefined. And this is the one that can be tricky at times. Cotangent is the reciprocal of tan, which is going to be 0. Because undefined and 0 are reciprocals of one another. I promise you guys you're going to have some of these on your quiz next time, okay? Pi is -1, 0, so sine is 0, cosine is -1, tangent is 0. Cosecant is undefined. Secant is -1, and cotangent is also undefined. Three pi over 2 is 0, -1. So our sine value is -1 because that's y. Cosine is 0 because that's x. Our tangent is undefined because I'm dividing by 0. So now if I do my reciprocals, the reciprocal of -1 is -1. The reciprocal of 0 is undefined. And the reciprocal of, I'm losing track here, cotangent would be tangent. The reciprocal of undefined is 0. Last but not least, okay, I have 2 pi here. We know 2 pi is the same exact thing as 0 because it's a full circle. We call those coterminal angles. So guess what? The ordered pair is 1, 0, and all these values are the same. So I'm going to say it's 0, 1, 0, undefined, 1, and undefined. So this is a huge deal right here. We definitely expect to see this on our quiz. Okay, once again, the way I got these is memorizing these ordered pairs, which we can see on this graph, and knowing sine, cosine, and tangent. So now we're going to go ahead and look at a particular angle, and all it tells us to do here is sketch in standard position and identify the reference angle. And just a reminder for us is that the reference angle is the distance away from the x-axis. So that's something for us to just kind of keep in our minds. So let's go ahead and look at this first one, which is 300. So if I'm graphing this, I know that 300 degrees is in quadrant 4. Okay, so I'm going to draw a triangle in quadrant 4. And I know that if all of this is 300 degrees, I need to figure out, well, how far away is this angle here from the closest x-axis, which in this case would be 360 degrees. So we're going to say that that is 60 degrees because I know that 300 plus 60 equals 360. So that's all it's asking us to do. Okay, our next one is in radians, and keep in mind we could do this a few different ways. I'm actually going to think in terms of radians here. So I know -3 pi over 4 means I'm going 3/4 of a semicircle, and negative means I'm going in a clockwise direction. So 3/4 of a semicircle would take me over here into quadrant 3. So I'm going to go ahead and sketch this. Okay. Same idea. We want to figure out how far away is this from the x-axis. I know that this axis right here is like pi because a semicircle is pi, and 3 pi over 4 is 1/4 away. So I'm going to say this is pi over 4. Okay, some of you guys could have done this in a slightly different way. If you had converted this into degrees, you would have seen that this was -135 degrees. And this would be 45 degrees away from the x-axis. So either of those answers would be correct. So these next problems are taking it a step further. It's asking us to sketch the angle in standard position and to evaluate the specific trig function. So if we're looking at cosine of 4 pi over 3, I'm going to do this in radians, but keep in mind, if we did this in degrees, technically we would get the same exact answer. So I know that 4/3 of a semicircle would be 1 1/3, which would bring me over here into quadrant 3. So I'm going to go ahead and draw out this triangle. I know that this is 1/3 pi away from the x-axis, so I'm going to write this as pi over 3 is my reference angle. Keep in mind pi over 3 we know is also 60 degrees. Okay, those are equivalent to one another. So if it's 60 degrees, there's a few different ways that we could do this. I know opposite from 60 degrees should be negative radical 3. It's negative because it's going down. Adjacent to 60 degrees would be a -1. It's negative because it's going to the left. And the hypotenuse is going to be 2, and that is always positive. We know cosine is adjacent over hypotenuse, so our answer here is going to be -1/2. Now, if you guys had memorized either the unit circle or the 9 trigonometric functions, you may have seen, okay, cosine of 60 degrees, or you may have seen a denominator of 3, so you knew what that ordered pair was, and you may have known 1/2 off the top of your heads. Then we know all students take calculus. In quadrant 3, only tangent is positive, so it would make sense that our cosine value is a negative ratio. Tan of -210 degrees. The first thing I'm going to do is add 360 just to make a positive coterminal angle, because I think it makes it a little bit easier. I know 150 is in quadrant 2, and 150 degrees is 30 degrees away from the x-axis, so I'm going to label this 30. Opposite from 30, we have 1. Our adjacent side is -3, and my hypotenuse is 2. I know tangent is opposite over adjacent, so I get 1 over -3, or -3 over 3. It would make sense that it's negative because in quadrant 2, only sine and cosecant should be positive. So keep in mind, there's a few different ways we could go about doing this. Notice I'm drawing it all out. I'm labeling all the sides of the triangle. Some of you just have things memorized, and that is great as well. Okay, number 5, I have sine of 7 pi over 6. Once again, there's a few ways I could do this. This is telling me 1 1/6 of a semicircle, which would bring me here into quadrant number 3. And I know if it's 1 1/6 of a semicircle, it's 1/6 pi, or pi over 6, away from the x-axis. I know this is also equivalent to 30 degrees. If we had originally converted this into degrees by multiplying by 180 over pi, I would get 210 degrees, which is 30 degrees away from 180. Okay, so we can do that in either way. So I have -1, -3, and 2. I know sine is opposite over hypotenuse, so I get -1/2 as our answer. Once again, all students take, it would make sense that sine would be a negative ratio. Okay, number 6 here, we have secant of -pi over 4. So if I'm sketching this out, -pi over 4, that tells me I'm going in the clockwise direction, and I'm going 1/4 of a semicircle, which would bring me here in quadrant 4. So I'm going to go ahead and draw this. That tells me it's pi over 4 away, or we could think of that also as 45 degrees away. And my opposite side is -1, my adjacent side is 1, and my hypotenuse is radical 2. I know cosecant is the reciprocal of cosine, and I know cosine is adjacent over hypotenuse. So this time I'm going to do hypotenuse over adjacent. So I have radical 2 over 1, which is radical 2. Now in quadrant 3, it's all students take calculus, which tells me cosine and secant are the only 2 ratios that should be positive there. Okay, the final thing we're going to do is just reviewing from last year how to use our calculator to evaluate trig functions. And some important things, we need to be aware of what mode we're in. And I know throughout the year you guys have asked me, is it okay I'm in radians? Is it okay that I'm in degrees? And we just really need to pay attention here, because if my angle is in degrees, then I need to use degrees. If my angle is in radians, I need to use radians. And we are rounding answers to 4 places past the decimal. Okay, sometimes we are also going to be finding an angle. Okay, and when we find an angle, we're using the inverse trig functions, and our answer needs to be between 0 and 360 or 0 and 2 pi. And we'll kind of see what that looks like. In order to do this, I'm actually going to transition to my graphing calculator, because I think that will just be a better visual for you guys. Okay, so the first thing I want to show you guys is how to change our mode. So if we press the mode button, if we look right here, we have radian and degree. I'm going to go ahead and move the arrows down to what I want. I'm changing it into degree, and I'm going to press enter, and it's going to highlight degree. Okay, and if you have the same calculator as I do, degree will now show up at the top. Okay, and we will have to work back and forth between radian and degree, so it's important that we know where that's at. So I'm going to go ahead and quit and get out of there, and now I'm in degree. So if we look at number 1, it says sine of 42 degrees. So what they're asking us to find here is a ratio. The angle is given to us, we need the ratio, and if you look, we have sine, cosine, and tangent right here. So I'm going to press sine of 42. I don't even need to press a degree symbol because our mode tells us it's in degrees. So I'm going to press enter, and it gives me a ratio of 0.6691. Okay, our next one says tangent, so I'm going to do tan of 58.23. And when I put that in, I get 1.615 as my answer. So when we have sine, cosine, or tangent, it's pretty straightforward. If we look at number 3, all of a sudden it's a little bit tougher. It says secant of 32.5 degrees. So we need to recall what we know about secant. I know secant is the reciprocal of cosine. So I'm going to do 1 divided by the cosine of 32.5 degrees. Okay, so I need to know which trig functions are reciprocals of each other. So I know it's sine and cosecant, cosine and secant, tangent and cotangent. And we know a reciprocal really means 1 over whatever the other value was. So when I press enter, I get 1.1857. So ratios, we're always rounding to 4 decimal places. Our next one is cosecant. So I'm going to do 1 divided by sine of 48.1. And we end up getting 1.3435. Okay, so these are the 2 different types of problems we're going to see when we are finding a ratio. The ones that deal with sine, cosine, tangent, like these top 2, and then the ones that deal with the reciprocal values, like these bottom 2. If we look at number 5, it looks kind of strange because it looks like number 1, but it doesn't have a degree symbol. So that's telling me it's in radians, so I'm going to go into my mode, and I'm going to change back into radians. Then press second quit to get out of that. So I'm going to press sine of 42. And notice it gives me a negative value. Okay, it's telling me that the ratio is negative 0.9165. And most likely the reason why it's a negative ratio is because having a radian of 42 means that it's in a different quadrant. Okay, everything else we're dealing with is going to be in quadrant 1 or 2, okay, because we know that, and actually it'll be in quadrant 1 for the most part because we're talking about acute angles. So I just really wanted to show us the difference between values we will get when we are in different modes. Okay, number 6, cotangent of 4 pi over 3. I'm already in radians, so I'm going to do 1 divided by tangent of, okay, I'm going to put 4, and then to get pi, we do second exponent, or caret, 4 pi divided by 3, and I end up getting 0.5774 as our ratio. Okay, the last one, number 7, I want to talk about that weird symbol. It says cosine of 54 degrees and 45 minutes. Okay, in degrees we have things called minutes and seconds. Okay, there are 60 seconds in 1 minute and there are 60 minutes in 1 degree. So we could do 2 things. We could go ahead and do 45 divided by 60, and if I do that, there we go. It tells me that it's 0.75, so I could do, first of all, I need to change my mode back to degrees. Okay, so I'm going to do cosine of 54 0.75. So that 45 minutes became 0.75, and it gives me 0.5771. The other thing that we can do, okay, if you guys press second and then this application button, it gives us angles. And I just want to show you guys these symbols, okay? Our first symbol is degree. Our second symbol here is minute. And then we have radians. And option 4, it says to convert to DMS. DMS means degrees, minutes, seconds. Okay, so what I'm going to do here, I'm going to do cosine of 54. And I'm going to give it a degree symbol. And do 45 second application to get me to that angle and give it a minute value. And notice it gives us that exact same ratio of 0.5771. So you can do it either way, it really doesn't matter. So that is how we deal with when we're finding a ratio. When we are finding an angle, that's when we're going to use sine inverse, cosine inverse, and tan inverse. So number 8 says cosine of theta equals 0.2891. So I'm going to press cosine inverse of 0.2981. And it's going to give me an angle of 72.7 degrees. And whenever we're dealing with degrees, we round to the nearest tenth. Okay, number 9 says cosecant of theta equals 2. So I'm going to do, I don't have a cosecant inverse on here. So what we're going to have to do here, I'm going to have to use sine inverse. And the reason why I don't do 1 divided by sine inverse is because I'm not dividing the angle. I need to go ahead and do the reciprocal of the ratio. So our ratio here is 2. So I'm going to do 1 divided by 2. Okay, so it's important that we always know that we find the reciprocal of the ratio, RR, reciprocal ratio, instead of finding the reciprocal of an angle. And I end up getting 30 degrees as my answer. Okay, so let's practice that again. On number 10, it says cotangent of theta equals 1.8572. I know that cotangent is the reciprocal of tangent, so I'm going to do 1 divided by 1.8572. And that gives us a value of 28.3 degrees. Okay, last problem here, secant of theta, so I know I'm going to do cosine inverse of 1 divided by 1.4974. And we get 48.1 degrees. Okay, so this is going to be really important in our next lesson that we know how to use our calculator correctly. The final thing I want to show us is what if we did sine inverse of that 1.4974? It's going to give me an error, okay? And it says our error is our domain. And if I go to whatever our problem is, okay, it's just telling me that there's something wrong with that ratio. And if we think about it, we know the ratio for sine is opposite over hypotenuse. Hypotenuse is always the biggest side of the triangle. So that means that the denominator is bigger than the numerator is, which means that the value of the ratio of sine has to be less than 1. Okay, so since this value is greater than 1, that is why it gave us an error. So if you guys get an error, it's important to kind of pay attention as to why you think you're getting that. So that's it for this long lesson. Hopefully we're feeling good. Please talk to me if you have any questions.